Hi everyone, my name is Martin and I'm the Director of Marketing at Evolvin and your host for today's session. So, I'm happy to have on today's session our guest expert from Forrester Research, Glenn O'Donnell, and Sasha Gillenson, Evolvin's co-founder and CEO. Glenn O'Donnell is a principal analyst with Forrester Research, serving infrastructure and operation professionals. He is widely regarded as a top thought leader in IT service management, IT operations, and the broader social implications of technology evolution. Glenn's specialties are in data center automation and operational excellence. He is the co-author of the CMDB Imperative, a book on CMDB best practices, and author of the recent report, Turn Big Data Inward with IT Analytics. Hi Glenn, glad to have you here today.
Oh, I'm thrilled to be here. Thank you, and thanks everybody else for joining.
Thanks, Glenn. Sasha Gillenson is Evolvin's founder and CEO. Sasha was the top guru in quality at Mercury and has advised numerous Fortune 500 companies on technology and process automation. Hello, Sasha. How are you today?
I'm doing great. Thank you, Martin.
So, before we begin, let's welcome all the attendees. Thank you for joining us. This should be very exciting. So let's quickly go over today's agenda. We'll start out with Glenn, who will present how to attain service fitness with change management analytics. Then we'll have a quick poll to hear your side of the story. And then Sasha will explain how IT operations analytics can take on chronic change and configuration challenges, followed by a brief demo. We'll follow up with a question and answer session. Throughout today's session, you can send questions using the GoToWebinar control panel located on the right side of the screen. We'll do our best to address all questions during the presentation and demo or during the dedicated Q&A session. So let's get started. Glenn, I'll hand it over to you.
Okay, thank you, Martin, and thank you, everybody. Happy to be here and talk about this whole point of change management analytics and what that means to you as an IT organization and as a professional. As you'll find out, change is a bit of a problem, and any of us who have been in this business long enough know that. So let's just jump right into the whole thing. We as IT professionals, we as a society in general, have made a lot of technological progress. We've moved on beyond some of the old technologies. We're playing with all kinds of new technologies. But you know, when you dig into it and you see what's going on, have we really made that much progress? You know, 3 Mile Island is a great example, and I'm going to highlight some of the reasons that 3 Mile Island had its issues. Great modern technology, certainly at the time, but some pretty serious failures. And what were the real issues with Mile Island? Well, it was really a series of change management failures that happened there. And, you know, it's improper maintenance procedures, a lot of poor communications amongst the various parties involved, complacency, people got lazy and kind of laid back and forgot to do certain things, got sloppy in how they went about doing things. It's a very complex system that even after the incident happened, caused a lot of consternation and really delayed the resolution to what was going on there because of all that complexity. And the real issue is that people had limited visibility. You know, some of the indicators were wrong. The complexity in the system itself limited their ability to really understand what was going on. And in the IT world, boy, doesn't this sound familiar. Complexity really is the big threat that we have. This is your 3 Mile Island. And I have a little graphic here to kind of illustrate how bad it really is. Complexity, as we know, this is Moore's Law or Kurzweil's Law of Accelerated Returns and a bunch of other numbers that show how complexity grows. It's growing exponentially. That's something we've all come to understand. Our ability to deal with that complexity is not. I think I'm being generous here, actually, insofar as our ability to do these things manually, to deal with all of this technology. It turns out it's actually worse than this, because what I'm showing here is theoretical complexity. Actual complexity is a lot worse because we have these step functions in the complexity curve that come along every now and then. I call them accelerants, or scientists and mathematicians will call it punctuated equilibrium. But the point is that it is a discontinuity in the curve, and complexity grows even faster after that point than it did before that point. And we've had these all through the whole life cycle of technology. We will continue to have these things come along. Things like virtualization, of course, that was a big one, because it took all of the world that we have and expanded it into this new virtual layer. But more importantly, it's put things in motion. Things were moving around a lot. Agile development is another one. Now everybody wants to go the cloud route, and mobile applications, the whole concept of mobility, bring your own device. Boy, this is really shaking things up. And each time we do this, it really makes the situation worse. Now, the point here is that up until the time where these lines cross, you can sort of get by. It's painful, but you can get by. After these lines cross, you've got a real issue on your hands. This is a real challenge for us all. So obviously, we need to do something differently. And this complexity really complicates the whole change management process. It makes it hard to make changes, because how do we know that we're going to make a change and it's not going to cause some ripple effect elsewhere? None of us wants to be the butterfly that causes the hurricane in the so-called butterfly effect. And we really don't know what's going to happen. So we have to do something. Now, it turns out people tend to think that they're pretty good at change management. This is some data that we did last year. We're about to kick off the new survey. But it's interesting to show that as people self-assess in the various processes that they're involved with, they tend to rank themselves pretty well in the change management process. Also rank themselves well in incident management. And I highlight release management because that's a special case of change management. So people think they're doing pretty well here. It turns out they're really not. So in that same study, we asked another question about how many of your incidents can be related to changes. And this is a pretty good barometer for how well you're doing at change management. So anything less than 10% is generally accepted as being good, but that's only 23% of the population. Not that great. 46% are known to be in the unacceptable range, with 5% really pretty bad off. But you know what? Even that 5% is better off than this 31% of people who don't know. If you don't know what you don't know, you got some real problems. The state of change management is not looking all that good. I have a new report that's out that highlights some good practices to help you with change management, and I highly encourage everybody to really step in and grab this change management bull by the horns, because if you don't, you're going to have some real problems. So why do people think they're good at this, but they're not? Well, there's two reasons. One is that compliance with the change management process is really not anywhere near as good as it should be. Everybody seems to have a change management process. They're just not following it very well. Or if they are, there's something woefully wrong with the process. And the other problem is visibility. This is the 3 Mile Island issue. People just don't know, and we've got to find out what's going on. We have to get some visibility into what's happening. Otherwise, change management will continue to be a big problem. So let's take a look at compliance first. Process compliance really is not enforced very well. To make matters even worse, they may enforce it too much. So too much draconian control over a change management process is not going to work either. So again, the issue is that people have the process. Enforcing that process is pretty hard to do. People are going to revolt when you try to enforce the process. This is just human nature. People don't want to be told what to do. And that's kind of what we're doing with the change management process. Revolting unauthorized changes continue to happen, and those unauthorized changes continue to cause damage to the services that we're trying to deliver. So what do? We lock it down even harder. And this is a real vicious cycle that keeps spiraling downward, and we've got to stop that vicious cycle. We've got to look at change management as being more flexible. So that's a big aspect. You can be nimble and you can have governance. And the issue here is not so much about control, it's about governance, and that's a big differentiator. And if you have good governance, process compliance will be good as well. You've got to give people an incentive to do the right thing, not necessarily force them to do the right thing. The real problem here is visibility. And it's visibility because we don't know what we don't know. And there's just so much complexity in the system that we don't really have that visibility anymore. And we certainly are not going to get that visibility if we try to continue the same old practices of manual discovery and relying on tribal knowledge and our expertise to understand all of this complexity that we're dealing with. So why is visibility the big culprit? Well, we've got these unknown unknowns. And if you can remember back to when U.S. Secretary of Defense Donald Rumsfeld gave a very confusing speech about known knowns and unknown unknowns about the war. It was very, very confusing, but he was actually dead on. It's these unknown unknowns, the things we don't know that we don't know, are the things that are going to kill us, and they always are. These are the ones that surprise us. So what we do is we wind up building defenses against these unknown unknowns. And how do you defend yourself against something that you don't know? It's really hard to do. And this puts in place a big culture of fear. And the bigger the fear, the bigger this overreaction. So we put more controls in place to combat these unknowns, and we just keep feeding the system. This is another vicious cycle. And what happens is you basically get to a catatonic state. You can't do anything. So this visibility, or the lack thereof, is not something that can be solved by force. This is something that has to be solved by technology and process and applying this in the right way with the right people. So let's get some visibility. This is really the bottom line. I'm a big stickler for this because if you don't have visibility, you can't do anything. It's kind of like driving down a windy road in the middle of the night and turning your headlights off. It's not a very smart thing to do, yet that's how we run IT. So we need to get some of that visibility. So we collect a lot of data. So we think, okay, we've got visibility. We're drowning in data. We've got more data than we know how to deal with. And in the introductory comments about the report I wrote on applying big data inward, this is really what it's all about. We've got all of this data. Now what do we do with it? Because even though we have all that data, we really don't have much information. And there's a big distinction. I'll dig into that a little bit. What we really need to get through all of that is analytics. And I say industrial strength analytics to help us sift through all of that data, turn it in, help us find all of these patterns in the data. And that's really what big data is all about. Now, most of the big data focus is on business intelligence and things that are relevant to your marketing department or somebody else in the organization. But if we're doing it for them, why not do it for ourselves? If we don't, we're going to continue to struggle and continue in a downward spiral. So let's apply some of that same thinking to the work we're doing in IT. And what we're really trying to find here is the truth. We've got all of this data, but once we really peer into that data, and only if we peer into that data in the right way, can we see what's really going on. And that's the truth. And the truth is going to help us in two major ways. One, it's going to help us with the whole reactive side of IT and the processes we're dealing with there. Incident management, incidents are going to happen. That's just a reality. We're going to have to continue to deal with that. But we have to be able to respond to incidents more quickly. We have to get that root cause identification and shrink mean time to resolution in a dramatic way because it's too long. It takes us too long to respond to these things and resolve them. More importantly, we don't want to be reactive, we want to be proactive. Now, yeah, that's a term that gets thrown around an awful lot. People say, well, let's do a proactive incident management, and our tools are proactive. Well, you hear a lot of that kind of noise, but all we've been doing is shrinking the reaction time, which is a good thing. But to be proactive, that means we're going to prevent these things from happening in the first place. And how you do that is through good design and engineering. Really engineering your services and the systems that support those services. You have to do good capacity management, make sure that we're not going to run out of steam somewhere along the line. And this is an art and a science unto itself. Cloud helps us in some regards, but it still remains a difficult thing to do. And change management, if we can be better with changes, we will be proactive. We'll prevent many of those incidents from happening. Back to the data that I was showing earlier, if we have good change management, we don't have as many incidents. Those incidents as a result of change can drop dramatically, and that's a great thing. Now, this analytics that we're going to apply comes in a lot of different forms, and you'll see as you explore this marketplace, and if you look at my report on analytics, you see I give some examples of these types of algorithms and such. There are economic algorithms that look at this from kind of a market-based perspective. There are statistical analytics tools that are always looking at data based on past performance. Configuration tools that look at your configuration parameters and how things are set up and built and make sure we have consistency and look at how that's changing over time. There are topological tools that look at the foot bone is connected to the ankle bone type of relationships, and relationships are all over the place here in the services that we're supporting, and a lot more. You know, there are many, many things that are involved in this whole analytics space. For the sake of today's conversation, we're going to focus on configuration analytics, because this is really the bottom line for good change management. If we're good at configuration, we're probably going to be good at change management. So let's dig a little bit more into that. And here's where I get a little kind of mathematical and scientific. And those of us who can recall back to our calculus days, remember the old dy dt ratio of trying to get a derivative of something. Change is really the derivative of your configuration. So as your configuration, in this case y, is changing over time, the delta, the change that's happening, is really going to be the change in the configuration state over time. So as your configuration state changes, you will get these marks that something has indeed changed, and you can see the scope of the change, how much of a magnitude the change was. The point here is that anytime something changes with your configuration, that's when you've got something you've got to deal with from the change management perspective. So if you understand configuration state over time, you understand change. You can identify when changes happen, and you can also plan for making changes and really be more proactive about how you make changes. So enough of the kind of scientific and mathematical side of it. Being a geek, I just had to throw that in, and many of you are geeks, so I thought you might like that. But really what we're trying to do here is, within change management, is trying to identify that, when changes have happened. And all of us in operations have come to understand that when the incidents are going off the charts and the service desk is busy answering the phones because everything's going crazy, the first question you ask is, what changed? And as you look at it, infrastructure, this is the stuff we've always been monitoring. We're always worried, well, the network's down or the server went bad or disk drive failed. Well, infrastructure doesn't go down as much as it used to. That's not something to worry so much about anymore. We don't have things going up in smoke. Most of the incidents are because we're making changes the wrong way. And if we're tracking some of the metrics, we have some key performance indicator that we want to watch, probably something really related to the applications. And we look at that as a statistical baseline, and we see that, okay, we've had something happen here at this point where we exceeded the baseline. And we know something happened. Now we have to understand why. Well, if we start looking at the various configuration items, the various configuration parameters and attributes, we can do a pretty good job of understanding a possible cause. And I say possible because if you just look at this very simple example, we've got attributes A and B don't change over time, so it's very unlikely that either of those was the issue. Attribute D, as in delta, doesn't have any obvious pattern to it, so that's not a good one to dig into. But lo and behold, attribute C did change at this particular point in time. So that gives us a pretty good indication, or a high probability, that this root cause. So we dig into it more and probably find out that it is indeed the root cause. But this kind of analytics is really important. And this is a very simple visual example. If you've got thousands or millions of attributes and thousands of different things that are sitting around in the world, it's not something you can do manually. This is where we need technology to step in and help us. And you can use the same analysis to be preemptive, to make sure that we're not making the wrong changes. The example I showed was really for incident management, but to be good at change management, to prevent these things from happening, to be proactive, you can use the same kind of analytics. And this is where we get into engineering. So I fly a lot, so I'm very happy that Boeing and Airbus and all the others build their planes using good engineering principles, because if they built their planes like we build IT, I would have been dead a long time ago. So what we're looking here is at the services that we provide, we really want to apply some good engineering practices. So good engineering does demand good visibility. You need to understand all the different parts and how those parts come together if you're engineering a plane. We have to be open to failure, but learn from the failure so that we can anticipate failure and use science. And good engineering is all about science, using that science to avoid the failure. Plan ahead, design for that failure so that it doesn't happen. And it's based on systems thinking. It's not understanding the server or the network or the storage or the applications even. It's how all that stuff comes together. And that's something that we really don't, we haven't done much of that in IT. And then as you're going through that design process and that development process, use a lot of models and play some what-if games. What if this happens? What if that happens? How is that going to impact the outcome? This is very analytical. And even though we have a lot of people in IT that call themselves engineers, I contend that we don't really engineer much of anything. Now, there are good examples, but good engineering is actually a rarity in IT, mostly because we don't apply that systems thinking. We're thinking in pockets. We're locally brilliant and globally stupid. We do great in those pockets, but we have to do great at how those various pockets come together. And then we've got, things are interrelated. It's no longer the type of scenario where if I make this change, it's going to impact this system and this system only. Well, as all these things are interrelated, and you'll find that relationships are very important in this understanding of configuration and change management. You get these downstream impacts, what I like to call the 6 degrees of Kevin Bacon type of analysis. So if we look over time, this scenario that I'm showing changes over time. So we have this circle at the top turned into a diamond just to indicate that it's a change. And there was a downstream effect. It didn't impact necessarily that first system, but downstream it had some impact, and we have to understand how that works. And to get to that understanding, you have to have the visibility into those relationships. So that's why the configuration information is so important to change management. Let's make sure we understand that before we make that change, plan for it, plan for the potential for failure, and design around it. So this whole issue of relationships and other dimensions of the data is the context that we need to really do analytics. Context is something that allows us to put the data into the right form. So here's just a very simple example that we've got some data that's just characters sitting around, it's gibberish. We can't make sense of it. So if we put it in the right context, if we assemble this data in a different form, we can, in this case, form some English language words. But it still doesn't make sense. Dalmatian, group, neon, think doesn't mean anything to me. But if I arrange them in a different way, it is something meaningful. One giant leap for mankind. It's those arrangements of the data. It's how we plug all this stuff together that makes it meaningful. And that's the difference between data and information. We need that information, and we need the context to turn all of that data into information. So when you say context, and having those concepts of relationships in place, you might be thinking, well, we need a CMDB. And I can even hear the eyes rolling as I utter that term CMDB. You don't really want a CMDB. Now, I wrote a CMDB book, but nobody wants to see that term die faster than I do. You don't need a CMDB. What you need is something we call a service information system. This is what the CMDB should have been all along. The CMDB was actually a great idea. It was just flawed in its implementation. And if you abandon the concept of that promise, of the CMDB, having the information necessary to make your decisions, you're making a big mistake. So let's revisit that. Don't go down the path of CMDB, and I have a lot that I've written on that topic, and there's a report on this service information system that's available as well. But the service information system is really a better CMDB, and let's just stop saying CMDB altogether. The service information system gathers data in what's known as management data repositories. This is something that ITIL v3, when it was introduced in 2007, said it's not a big database. It's a series of distributed or federated data repositories in various forms, and that's a great idea. The problem is it doesn't go far enough. It doesn't take into account process models. So you have IT processes and you have business processes. All of these processes are modeled as well. Another problem is that the configuration information and the service catalog have always been viewed as separate elements. They're not. The service catalog is a high-level abstraction model for all of the stuff that lies underneath it. And it also doesn't take into account performance information. So I've had a lot of conversations with clients who say, I want to build a PMDB, a performance management database. But the problem is if you keep that separate from the configuration information, you lose context. Each of these little lines and dials is representative and is therefore linked inextricably to some configuration item over on the left. So we have two buckets of data that we're interested in here with the service information system. One of them is structural information, good old-fashioned configuration, relationships, that kind of thing. And we also have behavioral information. And if we can put this data into an analytic engine, or more precisely, it's probably going to require multiple analytic engines because different algorithms, different technologies, different modes of sifting through that data do different things. That's when you get your decisions. And it's driven by policies that you can feed in to drive the analytic engine, that tell the analytic engines what to do. This is really a better view of the CMDB. And it's gaining popularity, and I'm pleased to see that. Now, changes are coming at a blinding pace. So that means we've got to automate, right? Well, yes, we do have to automate, but automation is going to need analytics. Otherwise, it's going to run amok. And we've all heard horror stories about how automation is going to run away on itself and do a lot of damage. It's going to if we don't consider that analytics is going to play a big role here. So looking at this model, there are really three buckets of technology in this taxonomy of automation. First is task execution. I want to do something, let the software do it for me. Repetitive kind of stuff, perfect. Now we're hearing a lot about process flows. How can we assemble all of these things into the right sequence and orchestrate them? Very good idea. But the third is decision triggers. This is analytics. It's not just monitoring. It's taking a look at the data and doing some analytics. The first two tell us how to do something. The decision triggers tell us why to do something. And that's a big difference. This is the overlooked side of automation. A lot of people don't see this as automation, but it really is. And it's a feedback loop. It's a feedback mechanism that drives all of these other things. It governs the behavior of the system. And so you've got to make sure that you're doing good things, because if the automation is merely going to accelerate the execution of what it is you're doing. So you want to do bad things faster, you want to do good things faster. Do good things faster and base that on the analytics and the processes that you're automating. That's a big deal. And preferably make this analytics at the application level. Look at everything, but it's the application that means everything. So you can use configuration analytics to really get big improvements in your change management. You can resolve incidents faster when they happen, the reactive side, and you can prevent changes from causing incidents in the first place because you can reduce the errors. This is the proactive side of change and configuration analytics. And when you do that, you're going to improve a lot of things. You're going to improve your service quality, definitely. You're going to improve your productivity because you can do things faster with fewer people. And you're going to improve your reputation. This is a big deal for IT because we have a reputation that's pretty crummy with the business, and we've got to do something about that. Otherwise, we're not going to have a future. So if you can do all of this and you can be integral to the business execution and the flexibility of the business, you've got a great future. And it all does start with visibility. And if you get that visibility, you're going to do great things. And you can attain this long-lasting service fitness, but it's going to take some work. It ain't going to be easy by any stretch, but a lot of people are doing it, and you can too. So thank you very much.
Thank you, Glenn. And that was very interesting. Okay, we're going to go on now with Sasha's presentation. So let me just turn things over to Sasha. And he'll be presenting his insights for IT operations analytics and how they can take on the chronic change and configuration challenges. Sasha, I'm going to turn this over to you.
Thank you, Martin. All right, so I will show you quickly how Evolvin solves the problem of challenge of analytics in changing configuration management space. So, as Glenn has mentioned, when you ask operations people about the changing configuration management processes, they generally believe that they have this process implemented. What we try to do, we actually asked a specific day-to-day, questions that operations team are dealing with to translate these challenges into something more comprehensible for them. And the result was quite interesting. While again the teams believe that they have changing configuration management process implemented, when we ask them if they know actually quickly what changed when an incident occurs, because as Glenn has mentioned, it's one of the first questions that are asked, or can the teams quickly identify what is the incident root cause when they try to solve the incident? Can they automatically verify the consistency of their environments to be on more proactive side? And can they actually validate when the changes moved in this environment that these changes, these releases are deployed accurately as they were planned and tested? And again, interestingly, when asking the specific questions associated with day-to-day operational tasks, 84% of the respondents, and we had more than 100 plus respondents at the Gartner Data Center Summit event, and ServiceNow Knowledge to Our Team conference, 84% said that they would like to improve significantly their ability to address this question in spite of all the tools and all the processes implemented in their organizations. Glenn has mentioned the reasons for this, why actually, this is so challenging to address these questions. It's a complexity and dynamics of the environments that are managed by IT operations folks. And just to give you some sense, some kind of additional specific numbers behind complexity, configuration and number of configuration parameters of WebSphere application server by IBM is about 16,000 configuration parameters. So we speak about the Oracle WebLogic server, then it's 60,000 configuration parameters. We speak about the average database, 45,000 configuration parameters, and so on. So when you look at the average enterprise environments, you speak about millions and millions of configuration attributes that need to be managed, because any simple single change in one of the parameters can actually take the system down. And still, the operations team are using very silo-specific tools to look and present their information to the other teams. The DBAs will be looking into database management tools, and system administrators into Windows, into operating systems, Windows, Linux, Unix specific tools, and application server administrators into their tools. So everyone looks at their piece of the data, and it's very difficult to comprehend the whole picture. So when we look into this, and if we try to take a different angle to this traditional chronic challenges of changing configuration management, we actually see that what we look at is a big data, because you have the volume driven by complexity, the velocity driven by the dynamics of the environment, and the variety, because you have very different types of information coming from different sources. So why does it happen? Why the existing tools cannot solve the problem? Glenn mentioned the challenges of CMDB, but there are other tools which are important for management of the environment, but still they don't deal well with today's challenges of big data. It's, if you look at the CMDB, one of the things that CMDB is providing is a bird's eye view. It has certain information about the relationships, and Glenn was talking about this, but it's from 30,000 feet. And when you look into the service desks and other tools managing and automating processes and workflows. So let's say it starts with service desk. You have change management process that you can initiate, a change request. The workflow will follow the approval processes and will get to the point of the signature and approval. But now, when the change will be deployed in the environment, how to know what actually changes these millions and millions of attributes I was talking about. And sometimes the organizations take a next step and try to collect this information, this detailed information. But just collecting this information gets lost in the noise. So the problem is that a new approach is needed. And that's the approach that of operations analytics, that's the approach that we are introducing with Evolvent. So what we actually do, we apply powerful analytics to take this most detailed and comprehensive end-to-end changing configuration data from all the layers of your IT environment, and we use analytics to turn the data into actionable operational insights, which are essentially the answers to this question that we were asking in our survey. Do you know what changed when you have an issue? Can you associate this information with the root cause of the incident you are investigating? Do you know if your environments are consistent? Is your release deployed correctly? All these are examples of the insights that analytics are providing answers for. And so how does this work? The technology actually has three major components here. The first of all, collection of information. You need to collect the data about the configuration and about the changes from the entire environment, from the application layer down to the infrastructure, to the middleware, database, operating system, everything. And you need to collect this information at the most granular level. All these individual parameters, all these millions and millions of configuration attributes, you need to get them, because a change can happen in any of these attributes. And that creates a lot of information. So it's already challenged to collect it without impacting the environment that you are collecting from. But then you also need to translate this information into the instance. That's where the analytics kick in. And what we do actually, we use a number of different methods. First of all, we use a knowledge-based driven analysis. So we have a knowledge base categorizing and prioritizing the configuration of different common technologies like operating system, databases, application servers, and so on. We actually use this knowledge base to identify which of the changes, which of the differences and inconsistencies between the environments could be critical and what kind of impact on functionality, performance, security, and so on these changes can have. The other methods we're using are statistic analysis. So for example, we use clustering analysis to get the context for the changes we are identifying, as well as learning, from many years of helping our customers. We also have heuristic algorithms that can verify correctness of the releases, that can analyze consistency of the environment and identify all those critical changes, the differences and inconsistencies that can either cause the incident that you are investigating, or they can be potentially harmful for your environment. It's very essential to represent this information in easily understandable way because operations folks are so busy. So it's important to provide this insight in the way that can understand and use it quickly. So we have web-based visualization of this information with all the drill downs. And then, as any enterprise monitoring solution, we have alerts mechanism, we have offline reports, notifications mechanism, and so on, allowing our customers and our users to get access to information from any point at any time. There are 4 key use cases where our technology is used by the enterprises. So one of them is actually a reactive one to cut incident investigation time. Using the analytics, you can compare, for example, non-working and working environment. Very frequently you have a situation when one of the servers is not working, another single one is actually is behaving correctly. So what is the difference between them? That's what analytics can help you to identify. What is the difference that might lead to the incident? Or you can monitor for suspicious changes, the changes that could be a root cause of the investigated issue. More proactive use cases are accelerating releases, updates, upgrades, and changes by validating that all the changes are deployed accurately. You can actually compare pre-production and production environments, and again, there are many differences between them. So it's important to use analytics to see the changes were transitioned correctly, and the differences that exist are legitimate differences that will not impact environment after the change. Also, to avoid the risk of the change, you need to be able to monitor for environment drift. You need to be able to identify those unauthorized and unplanned changes that bypass your change management and configuration management processes. We can set alerts that will notify users to the changes of sensitive configuration items. So for example, when you freeze your environment for the end of the year or for quarterly reports or any other reason driven by your business needs, we can actually inform you if someone breaks this environment and introduce any change. And then the kind of ultimate health check, ultimate proactive use case is automatic analysis of consistency between the environments. So you can run analytics across multiple environments and ensure that they are consistent. There is consistency both within the environment. So for example, clustered and load balance servers are configured the same way. And there is also consistency across environments. So disaster recovery is similar to your production environment, and your pre-production is representative of production, and so on and so on. So if we will summarize, what are the key differences of Evolvent's analytics solution, it's first of all the ability to apply analytics to look for the specific information that is important for stability of your IT environment. We provide a single point of view for all the changes across end-to-end environments, all the different layers, all the different types of the environments, physical, virtual, cloud. And this analysis is based on everything that matters. We cover entire environment from application through the entire software infrastructure stack down to the infrastructure and hardware. We drill down to the most granular level of configuration parameters in any configuration source. So it's a very granular, fine-grained information. And what's important is that we do these collections dynamically without any coding, any programming, any preliminary setup, so that we can capture all the latest changes practically out of the box. The results are in minutes. We have both software as a service delivery model as well as on-premise solutions, so you can use both. And what's important is, again, from the point of deployment of the product to the actual analytics kicking in and bringing the results, it's literally minutes. So let me show you quickly, what I mean by saying that it's easy to use and powerful tool. So right now, we actually should be able to see a browser running, a console of Evolvent Operational Analytics. What you see here is an inventory, where we see along the left side a list of all the servers and services monitored by Evolvent. So here we see what we call logical environments, or logical services or business services, as well as physical and virtual servers we are monitoring. And we can, just to give you the sense of granularity of the information, let's look at the operating system configuration we are capturing. So we will be collecting information from file systems, from etc files, from Windows INI files, as well as we will be collecting information about hardware of the system, BIOS, network configuration, disk configuration, memory, CPU, and so on. But what's important also, we'll collect information about software side of the operating system. So we'll collect information about the drivers, about the installed components, updates, printers, services running, and also kernel configuration. So what you can see here is a visualization of our knowledge base. So what you see, the Thunderbolt signs actually represents the criticality of each of the parameters and a potential change that can happen, that will make an impact if this parameter is changed. So red one always is the most critical changes, potential changes, and yellow the significant but not critical ones. On the right, you also see the type of the impact. What will happen potentially if this parameter will be changed? Will be this impact on functionality, performance, availability, localization, security, and so on and so on. Now that we have all this information, how can we use it? So let's say we have an issue. So we can go and to the monitoring tab, and we can actually see, all the changes that happened in the system. The system breaks them down, and you can see where this changes happened: an application server, a database, an operating system, and so on. It's a pretty significant amount of changes, but we can actually use analytics to narrow down this significant amount to the specific ones that we're looking for. So let's say that our issue is with the performance of the application servers. So one of the things that we'll do the first, let's break it down by authorized versus non-authorized changes. Were there any changes that bypass change process on our application server? So we see that there are non-authorized changes. So let's do the following one. Let's see the next step of the analysis, still pretty significant number. So let's do the analysis now and see, if there were any changes were done manually that just bypassed also the automatic deployments, more dangerous changes. And we see that there are manual changes that were done. So let's see who did these changes. And let's do it by the user. And we can see that there are, three users. Some were done using the administrator user, but there were two other specific users that did the changes. So we can actually, at this point, while investigated, we can approach this specific specialist and ask them why the changes were done and if they can have an impact we are investigating. Now, alternatively, we can see what kind of type of the changes, where they're done manually. And we apply our clustering algorithms, and we see that mostly there were changes in application files, some configuration file was changed, and number of XML files was changed as well. So again, for the specialist, it gives a context to understand what kind of the changes were introduced in the system. Another scenario will be a consistency of our environment. So instead of looking for the changes of in the specific environment, we can look at across our environments and see if these environments are consistent. So we can compare our production, pre-production, QA, and other environments, and we see that there was a significant number of inconsistencies introduced at some point of time, with less inconsistencies introduced, differences introduced in the second week of January. Now, that's again a significant number of differences. What can we do? We say that's a golden, the golden baseline of our environments. The environments are working. We are okay. We'll take it slowly and analyze these differences. When we have time, let's see if there were any inconsistencies introduced over the last month. We're looking for the entire last year, and actually, we see that there are no new inconsistencies. So we say that's okay, meaning that our environments stayed at the same level of consistency as they were back in January. So there are other numerous scenarios we can demonstrate, but we're running out of the time. And Martin, at this point, back to you.
Thank you, Sasha. That was great. Let me just take over here. We've had some great presentation here and some really good questions that have been coming in throughout the session. So I'd just like to bring up some of these questions. Glenn, we have a question here for you.
Okay.
Isn't it just a process thing? Why not focusing on improving our change processes?
Yeah, I get that a lot. Well, it is about process, and as I noted with the automation comment, if you have a lousy process, you're just going to do bad things faster. The problem is, some people get overzealous about the process, and they say, well, if you got a good process in place, changes are going to go well. Well, that's all fine and dandy, and yes, you do need great process. You need it to be solid, and you need to be flexible. A good process does not mean you have to wait 2 weeks to make a change. But no matter what, we need some assistance in the decision side because the complexity has far exceeded our ability to understand what we're dealing with. So we don't have visibility despite having a good process. So you need process, but you really need the visibility to help you make those decisions and execute the process the way it needs to be executed.
Got it. Okay, and Glenn, do you see IT analytics getting traction with customers? What's the future for it?
It is getting a lot of traction, and I think this is one of the hottest areas of management and automation right now, precisely because people have come to that realization that the world has gotten too far out of control, and they now need the software to sift through all of that stuff. And big data is it's a real buzz term right now. Everybody wants to be a big data player,
So you're seeing a lot of stuff being branded big data. I wouldn't get too hung up in that, but I would certainly focus heavily on the fact that there are technologies out there that help us make sense of all of this chaos, that can help us make these decisions by giving us the visibility and doing something with that visibility. We don't really have a choice. The world is far, far, far too complex. Even our best and brightest people can't do it anymore. And taking all of our best and brightest people and putting them all together still doesn't do it. It's just gotten too far out of control. Only software and only technology has the ability to really get some insights there. It doesn't mean people are obsolete by any stretch, but the smart people need smart help.
Thanks. Okay, we're tight on time, so we got one more question. Sasha, does Evolvent integrate with Service Desk?
Absolutely. Part of the value we can provide, we could be a standalone solution, but with a service desk, together we could be smarter. So we can close the loop of the processes managed as a service desk, such as incident management, configuration, and change management, adding the information and adding the analytics about the actual changes that happen in the configuration and in the content of the environment managed by IT.
Okay, thanks. So I'd like to thank you all for taking the time to join us for this session. I personally found this to be very interesting. Also, as always, I like to hear from people who attended our sessions. So feel free to drop me a line with any questions or feedback, or contact us to schedule a discussion or a live demo. So on behalf of our team, I want to thank you all for taking the time today for joining us. We'll be sending you all a copy of this presentation. You want to learn more? Visit our website and check out our resource section and presentations, or sign up for the blog feed. And once again, thanks, Glenn and Sasha.
Thank you. Enjoyed it.
Thank you, Martin.